In this lecture, I am going to explain the UDP attacks. In the earlier lecture, we have seen the ICMP attacks. The ICMP and IP are related to the network layer. Now we are moving on to the transport layer. In the transport layer, the TCP and UDP, these are the two popular protocols that are going to be used. Anyhow, whatever the upper layer protocol it may be, they have to be included in the lower level protocols, and the functionality or traffic has to be sent out. So the UDP means the user datagram protocol. At the transport layer, there are two main protocols, as I just now told you, that is TCP and UDP. And here TCP is especially used for the connection oriented thing, and where in case of UDP, UDP is especially used for connectionless. So what is the main difference of this connection oriented and connectionless? So why do we need UDP or TCP at the transport layer? That is the first question we need to answer. Then only we can understand its functionality and what is the need of the transport layer, and why these particular protocols are required for communication. So on a single host, there might be many applications programs. IP only identifies the host, but not the programs. So these UDP and TCP at the transport layer will provide you how to identify the program. So the network layer is only focusing on the address. Okay, that is the system address. So we need another thing to distinguish one application from another. So when the TCP IP software receives a packet, it knows which program to send. TCP IP uses the protocol port number to distinguish the program. Applications programs bind themselves to the port numbers and work. So whatever the datagram that received up to IP level, whenever it is escalated to the upper layer, which is the network layer, at the network layer, at the transport layer, sorry. Whenever from the network layer to the transport layer, the datagram has been escalated, then at the transport layer, that datagram may belong to any of the program, and that program may be binded to any port. So the transport layer protocols will mainly focus on the port identification and sending the data to the corresponding port. So that is the reason we can say this TCP/IP communication is also said to be the socket communication. So here IP address plus port number will come into picture. So both TCP and UDP have port numbers. They are different. They are in different port numbers. So some dedicated to the TCP and some dedicated to UDP, like that. We'll see the port and port scanning techniques after in this course afterwards. For currently, you understand that TCP and UDP will mainly focus on the port. At the same time, they will identify uniquely the program that is intended for to receive the data. So the UDP is a transport layer protocol, and it is a connectionless service. That means that the user and that is sender and receiver, need not be ready to receive the communication. So that is the reason it is said to be connectionless service. Same best of effort semantics as of IP. So IP is also a stateless, or you can say connectionless thing, because IP don't have the capability of identifying the routes and all. So that is the reason it will depend upon the ICMP protocol, which will mainly focus on the identifying of the best route and knowing about the congestion, etc. So in the same way, UDP also don't have that means it won't guarantee the best of effort delivery. However, it will try to give the best of effort, but even though the packet lost, then the packet cannot be retransmitted back like TCP. So same best of effort semantics as IP. Messages can be delayed, lost, or duplicated, and messages can arrive out of order also. So whenever messages arrive out of order, then it is the responsibility to rearrange in the proper order. In case of TCP, what will happen if the messages were arranged, if the messages are received in out of order, TCP will maintain a buffer so that the TCP will, what it will do is it will rearrange all the packets in a sequential order. So you will get a perfect quality of service there. But here in UDP, you will not get like that. Application accepts full responsibility for errors. UDP based applications are like this: domain name services, the such as domain name services, which are especially used for resolving the web application related things, like resolving the web names, that is website names and all, are totally deals with this the UDP application, domain name service, and simple network management protocol, trivial file transfer protocol, routing information protocol, Kerberos, which is a security system. These are the applications, especially mainly focused on the UDP services, because here there is no strict need of the data to be presented exactly. So that is the reason UDP is more popular. So where exactly this UDP will be used is, even though some packets were lost, still the communication can be managed. In such a situation, we can use the UDP. That is actually the question is, why do we need this particular UDP protocol? So this particular UDP protocol, especially used in the heavy packet streaming, like video streaming, and where you will find thousands of packets are to be forwarded to its users. So acknowledging packets is somewhat troublesome, because you cannot acknowledge every packet in such a setting, like especially video configurations and video streaming and all. So even though some of the packets were lost, still you can manage the video. You can stream. You can manage the video or audio or video, or this kind of thing. In such a cases, UDP can be used. So that means wherever the uh, even though some packets are lost, still the communication can be manageable. There, UDP can be successfully used. Otherwise, what will happen? Even though a single or a small packet was lost, again the retransmission has to be taken place if you use TCP protocol. Sometimes this utilization may increase the consumption of the power, and that may drain the batteries in case of wireless communication. So that is the reason in wireless communications, especially the UDP communication is used for even though it is unreliable, but it is used in the wireless communication. So basically, this UDP is used when acknowledgement of the data does not hold any significance. In such a cases, this UDP is popularly used, and UDP is a basically UDP is a good protocol for if the data is a unidirectional data. That means if you directly send from source to destination, that's all. Destination has to receive. So just like broadcasting and all, broadcasting or multicasting, this kind of thing, this UDP is a better way of thing. Or we can say, I want to get the time information, or I want to get some information about the configuration from a server. So then UDP is better to use. In such a cases, UDP can be used. Okay, and UDP is simple and suitable for query-based communications, especially like network time servers. You might have seen in your mobile phones or your laptop or somewhere, wherever the CMOS battery or battery was removed and replaced. If you don't have the mobile tower signals or something, then time cannot be adjusted properly, right? So time cannot be adjusted properly. You are supposed to manually set it, or time cannot be get automated. But if it is connected to any mobile network, or if your laptop CMOS is changed, and if you might have connected to the internet, what will happen? The time and date settings will be automatically updated. That you might have seen. So how is it possible? That means your device is connecting to the network time server, and it is getting the information from the network time server and updating at your system at. So this kind of queries will be fired with the help of the UDPs. That is, UDP is the underlying protocol that will be used in such kind of queries. So it does not provide the congestion control mechanism like TCP. And one more thing is UDP does not guarantee ordered delivery of data. As just now I told you, at any order the packets can come. And the finally I can say that UDP is more suitable for this video streaming and voice over internet protocol and multimedia streaming. This kind of applications where UDP can be used successfully. And here, as I told you, the TCP and the UDP mainly focus on the ports. So here, reserved and unavailable UDP port numbers will be there that are most popular and dedicated, that will be used by many services. Small number of reserved for specific applications called well-known ports. Some interpretations through the internet used by the server softwares, especially like 7, that is port number 7 for echo and 13 for daytime and 53 for DNS services. So these are the port numbers that are especially used for UDP services for getting the services from the corresponding servers. So with this information, we'll move forward and we'll see the packet structure and all. So the UDP encapsulation will be done like this. There will be UDP header and UDP data area. The reason is it is in the transport layer. Whenever it is in transport layer, obviously this has to be come down to the network layer. Whenever it is coming to the network layer, again in the network layer, the most popular protocol, which is the IP, is there. IP header will be there, and in the IP data area part, this UDP header and data area of the UDP will be fitted, and that means it is encapsulated in this. Again, this IP packet will be IP data will be fitted into the frame area, which is at the data link layer, and finally it will be converted into raw bits and will be transmitted. While coming to the message format, here source port, which is also again 32-bit. Here the length is source port is 16-bit and destination port is 16-bit. Length of the UDP message and UDP checksum and beginning of the data. So this is especially UDP format. It's a very simple format, UDP format. No complexities, nothing. So since UDP is especially used for the recommended to use for the video streaming and this kind of thing. So here, whenever the video streaming was happened, then the concept of multiplexing and demultiplexing will come into the picture. Multiplexing in the sense combining multiple things in one stream, and finally at the receiving end, demultiplexing will be taken place so that we can browse through the we can browse through the communication independently. It is just like in your TV channel, in your television. Whenever you attach the Tata Sky or any other set-top box, the if you look at because of the set-top box, you can be in a position to view hundreds of channels in your television. Are you going to maintain? Are you going to maintain uh, independent wire for every channel? Obviously, no. So you only one wire you are going to get from your the Tata Sky or any other DTH dish, and you are going to get into the setup box. From that, you are going to get into TV. So with only one wire, this many number of channels are coming. So how is it possible? This is multiplexing. Okay, many channels, and its received its signal range or frequency ranges will be fixed in one bandwidth, and that will be captured by your DTH, and it will be sending to your television via set-top box. So only via tuning the channels, tuning the frequencies. That means shifting the frequencies via channel numbers. So you are getting the different channels. So that means you are not using a single wire for particular independent wires for independent channels. You are using only one wire for one channel, multiple channels. So this is what is called multiplexing. So this multiplexing means multiple channels will be combined into one band and will be sent. So this is what is called multiplexing. But the receiving end demultiplexing will be taken place. So here IP module is there. The IP module will send the data, and at the UDP, whenever it receives the UDP what it will do is it will segregate that datagram to which datagram has to send to which port. So UDP is linked with multiple ports. So automatically, whenever the datagram has received at the UDP level, it will divide it. It will segregate to which port this has to done. So while coming from the IP module, it will come in one stretch. That is like a one band. But which port that particular corresponding data service has to be utilized. That related port it will be transmitted. So where it will be looking like a demultiplexing. So this is called from IP module, whatever the content is getting the multiplexer one, and from here sending the services or the data to the corresponding services by UDP is said to be the demultiplexing. And one more thing you are supposed to classify is the datagram and packet. Where exactly this datagram will be used, where exactly the packet will be used. Packet is especially used when there is a connection between the source and destination. Like for example, TCP. So TCP is a connection-oriented protocol. Whenever you use a connection-oriented protocol, there the communication unit is packet. Okay, wherever there is a connection-less protocols, that means either UDP or IP at the transport at the network layer, UDP at the transport layer. Whenever the data unit of such protocols are said to be datagrams. Okay, because datagrams don't have any state information. So that means any kind of data can be combined into one unit, and that will be sent out. That means I want to communicate this datagram in a stateless way or connectionless way. The services which are running on 1002, service running on the port 7, service running on the 51 may send some data out. So what I will do is I will combine in one particular unit which is called datagram, and that datagram will be sent out. Where in case of TCP, it is not like that. The independent unit is said to be packet. Okay, that you must remember the difference between the datagram and the packet. So this is the overall structure of the UDP. Now we'll see the UDP based attacks. On UDP services, the possible attacks will be like this: Fragile attack. So broadcast UDP packet sent into the echo services. All computers reply with the reply messages. Source IP was spoofed. Victim is overwhelmed. Similar to the ICMP Smurf attack. So in the ICMP Smurf attack, what will happen? A fabricated IP will be generated, or a a attacker will spoof an IP address in the computer network's range or a network range, and it will send a broadcast echo request with the fabricated IP, so that all the any other computer receives this echo request will reply with the reply request with the reply message to the IP address who requested it. So automatically all the reply messages will go to that IP address, which is called as the ICMP Smurf attack that we have seen in the ICMP attacks. The same kind of technique will be used here because there is no communication of acknowledgement or something in the UDP. It is also stateless and connectionless. So that is the reason. It will work similarly to the ICMP Smurf attack. So that is this is what called as a fragile attack in case of UDP. Next, coming to the UDP ping pong attack. Some services or application issues a UDP reply no matter what is the input the packet is. So whatever the packet it receives, but some services always will keep on giving the UDP replies, whatever the message it receives. So those are very dangerous. So set the source and destination ports of the UDP to be one of the following ports, like a daytime, which is 413, time 437. This causes a ping pong effect between the source and destination. So for no reason, the systems are giving you, or some services are giving you UDP reply, and in that reply, always this port by default ports like 13 and 37, and generally commonly used ports were set. Then automatically this causes a ping pong effect, means always giving you some tapping or some ringing to the server that is between the source and destination. So that means the systems will always busy in responding to this instead of doing their own works. So this is what is called UDP ping pong attack. It is just like I will tell you one example. Like in many of the big apartments and societies, some mischievous kids will be there. What they will do is, as they are going, just simply they will click on the calling bell and they will go. Okay. So what will happen? The one who are inside that home, okay, apartment, they will come out and they will see who is there. Okay, but they will find that no one will be there. So this is what is called UDP ping pong attack kind of thing. So for no reason, simply they will send the UDP replies. So the one who receives that will always keep on checking. No, I have not sent the reply. I have not sent the request. How I got the reply. So they are in busy in searching for that only. So like that, here also the UDP ping pong attack will be happened. So next one is the denial of service attack. So especially this UDP denial of service attacks will be happen like this. Um, Usually, whenever UDP request has been sent, the reply has to be sent in a normal way. But what will happen in the denial of service attack? Applications that reply with large packets to the small requests. So even though I have given a small request that I get, okay, I know I need only this some KB of data, but the replies are coming with a huge size of packets. Okay, then the system may not hold that much packet size, or that much traffic cannot be holded by the system, thereby system may spike up. Thereby it is leading into the denial of service attack. For example, the example games like Battlefield 1942, Quake 1, and Unreal Tournament, these are the games which are very popular but failed because of this attack. They whenever online game, these are the online games, whenever they are playing, if any request are sent, a huge number of packets will be sent to this game, then automatically system may not receive that much packets at a large number of sites, so thereby the system is getting stuck. So host can be attacked by using these applications as amplifiers with the forged source IP packets. Later on, they discovered that with forged source packet IP address also, the amplification attack can be performed. Thereby, the one who are using these games cannot do any other task other than this. So sometimes the systems are very stuck up. Thereby, it is leading into denial of service. So in this way, the denial of service attack will be performed using UDP. So these are the general attacks that are on the UDP. One is the Fragile attack, which is like SCMP Smurf attack. Another is ping pong attack without no reason. UDP replies will be sent by some services. And denial of service, even for small requests, huge packet size or large packets with a large size will be sent to the requester. So these are the three things was found as the main vulnerabilities in many of the services with respect to UDP. Thereby, UDP attacks are going to be performed. So this is regarding the UDP attacks.